Okay, so let's recap for the review 3. For number 1, we got f prime of 4. That's what we're looking for. Pretty straightforward. F prime, plug it in. For 2, we're trying to find the area of that shaded region. Again, not actually find it, but what is it? Well, if notice all these looking at these, okay, we do have a dy, but the other integral and stuff is dx. So let's go ahead and do that. If we look at dx, so the vertical line here is going to be d minus f of x from a to b. And that's what I have, d minus f of x from a to b. So that was choice B. Now what's wrong with this one is that for us to get f of y, it's not f of y, it's got to be f inverse of y. And the other problem with that is that would be all the way to the y-axis. We have it to a, so we'd have to cut it off. That's part of the problem. These other ones are trying to get you to look at it like already doing the fundamental theorem. Okay, so 3. Here we go. Here's the written out. So we plug it in, we get infinity over infinity. Lose the L'Hopital's rule. Take the derivative numerator, denominator. Done. Again, L'Hopital's rule again. Numerator over denominator. Derivative, derivative. Infinity over infinity again. Another indeterminate form. Derivative numerator, derivative denominator. Finally get a constant, which is 3. Yes, you could use the leading coefficient test you used in pre-calc, but this is the calc avenue. Okay, so in B, sorry, not B. So number 4, what's number 4 looking for? Okay, function's continuous over all real numbers when x is not equal to -2. And then when x is equal to -2. In other words, if we plug -2 in here, we get an undefined value for f, but we notice we had 0 over 0. Indeterminate form, so the limit does exist. Okay? So we just got to find out what other piece is going to fill in that hole. So that's exactly what we do here. So where's the limit? If that's equal to the function value, again, the third piece of the definition. And instead of using the L'Hopital's rule, I simplified. Plugged it in, plugged -2 in, we get -4. So f of -2 is -4. It covers up that hole, that removable discontinuity. Okay. 5 is, what is the dy dx? What's the derivative? Implicitly. So derivative of x cubed, derivative of 3xy. So 3 times the derivative of x times y, plus 3 times x times the derivative of y. Then plus 2 times y cubed, so what's the derivative of 2y cubed? 2 times 3 times y squared, dy dx, and the derivative 17. Dy dx is on one side, without them on the other, so when I subtract it over, now when I go ahead and divide it by that, so I subtracted those terms and factored out the dy dx. But when I did that here, notice all the options, none of them have the negative inside, so I factored that negative, the common factor of -1, out in front of the whole thing. So when I divided by this, oh wait, common factor 3, take it out. Area of the region enclosed by the curve and the x-axis. Well, I know that's a rational function, not going to equal to 0 with the constant, so this is all below the x-axis, or below the curve, from 3 to 4. Also, I know those are positive values when you plug y 3 and 4 in. So here we go, right here. So again, you could use the substitution of u is x minus 1 derivative of d. If u is x minus 1, du is dx. But we should be able to take a look at that, getting better with that. That's just a natural log of 1 minus x. Plug in 4, plug in 3, normally, get to here. Not one of the options. Remember the logarithmic rule of logarithms? If you subtract logarithms of the same base, it's same as multiplying. Okay. 7. Equation of the tangent line at that point. So what's the slope of the tangent line? The value of the derivative at 1, 3. So that's first. What's y prime? dy dx, whatever you want to call it. So derivative 2x plus 3 times 3x minus 2 minus derivative of the numerator, which is 2x plus 3, times the derivative of the denominator, all over the denominator squared. Now, only in terms of x. Notice I didn't bother simplifying. Since I'm evaluating, I'll plug it all in. Plug 1 in. Nice, quick, boom, get negative 13. So y minus 5. So this would be good if all we're doing is slope of a line, free response, but it isn't. It's multiple choice. So got to make it look in the standard form. So distributed 13, combine like term, move the 13x over. Alrighty. 8, straight derivative of both of those. If you have d instead of e, remember derivative of cofunctions, we get the opposite, so it's actually minus a negative. 9. Does look pretty straightforward when you think about it. Just composition of functions. We'll take a look at that here. Now, what happened to the absolute value? Well, remember when you square anything, any real number, we get a positive. So the sign involved in the x, when you square it, is not going to have an effect. It's going to be just like x squared. So we can simplify it that way. And 10. F prime. Oh, we need to use the product rule. So derivative of x squared, or the x minus 1 squared times sine of x. X minus 1 squared times derivative of sine of x. Plug in 0. Done. Now in 11, in the free response here, how do we find a and b? Well, here's the two things. We got the function that's got a local minimum and a point of inflection. Well, local minimum is going to occur when f prime is equal to 0. Point of inflection occurs, yes, we know second derivative changes signs, but that means the second derivative at negative 2 is equal to 0. So f prime set equal to 0, get an equation with just a and b. F double prime, get an equation with just a. So we can solve for a, plug it in, find b. Notice, showing f prime and f double prime is a point apiece. Plugging them in and showing that they're equal to 0. So this step right here, so our 4 out of our 9 we were talked about earlier, is right there. And 1 point for the solving. B. Okay, here's what's the value of k. In other words, what's the antiderivative? From 1 to 2 is equal to 32. Well, antiderivative of x cubed of 4x cubed plus ax squared plus bx plus c. Actually, I'm going to put in the 36 and 24 for b and a respectively here. So antiderivative, fundamental theorem, set equal to 32, solve. Again, antiderivative, so you got to this would have been 2 points. Boom. I think if you got one error, you took one off, 2 errors, you're done. So the expression has to be in kth, so that means it's down here. And of course, finding k to be 5. And lastly, 12. Find d, the second derivative at that point. Well, notice it's the derivative at that point. So now what can we do? We got a couple of different things. I just went ahead and took the second derivative, so the product rule. Derivative of the first, again, what's the derivative of y, dy dx, times the second, plus the first y squared times the derivative of the second. Now, you got a couple different avenues here. I went ahead and evaluated dy dx at that point 3/1/4, got 0. So I plugged that in here, plugged the y, plug the x in, and evaluated. You could have, and when you look at it, take this here, and if we're looking for what is the the second derivative, not evaluating, you'd have to take this dy dx and plug it right in here and then do algebra. Simplify it. You could do that. I just thought I'm plugging in because I'm evaluating. So 2 points for the second derivative. You don't do the product of chain rule, you're done. And our basic separate, antiderivative, separate, integrate, find, don't forget your c, find c, solve for y. Pretty straightforward. The only weird thing is maybe the reciprocal of 1/4 to get 4. And then simplifying, solving. So you could take the reciprocal of both sides. You really could think of this as over 1 and do a cross products kind of proportion thing to get this. You could distribute the subtraction first, so -6x plus x squared plus 13. Take the reciprocal. Either way works.